Okay, so the first example that we're going to go over is we're going to go back over the residual, so I make sure that you 100% understand it. So a residual is the difference between the y value of data point and the corresponding y value found using a line of fit. Okay, these are the y values. We're going to use number 5 as an example out of the homework. These are the y values given. So these y values will be compared to y values that we get using our model or line of best fit. This right here you can term as model or line of best fit. Okay, we are going to get these values by plugging the x values into our model equation. So if you plug -4 into the model equation, you will get -21. If you plug -3 into the model equation, you'll get -17. -2 into the model equation, you will get -13, -9, -5, -1, 3, 6, and 11. Okay, what we are wanting to do is compare these values to these values. So we are trying to determine if our line of best fit is actually truly representing our data points. In order to find the residual, what we need to do is we need to take -18 minus -21. So that will be 3. -13 minus -17, that will give us 4. -10 plus 13, which will give us 3. -7 plus 9 is going to give us 2. And the rest of these values are 3, 1, 3, 4, and 4. So go ahead and take the -2 minus the -5, which gives you 3. The 0 minus the -1, which gives you 1. The 6 minus 3 gives you 3. The 10 minus 6 gives you 4. The 15 minus 11 gives you 4. Okay, once we've gained this information, what we can do is plot, they term it residual points. So what we want to do is we want to take our x values, and then we also want to use our residual points. So we're going to have -4, 3, -3, 4, -2, 3, -1, 2, 0, 3, 1, 1, 2, 3, 3, 4, 4, 4. With these plots, what we can do is we're going to plot these and see how these points disperse. Okay, so let's go ahead and make our T here. This will be the axis where all the residual points are on. And this will be the x-axis. Okay, So we have the point negative 4, 3. So we go 1, 2, 3, 4, 1, 2, 3. Okay, we have the point negative 3, 4. So we go 1, 2, 3, 1, 2, 3, 4. We have the point negative 2, 3, 1, 2, 1, 2, 3. We have the point negative 1, 2. We have the point 0, 3, 1, 2, 3. We have the point 1, 1, 2, 3, 3, 4, and 4, 4. Okay, what we are trying to do is determine a pattern from this. So let's go ahead and go back to our example and see what it says about the residual points. So if the model is not a good fit, then the residual points, once again, these are the residual points that we plotted, will form some type of pattern that suggests the data are not linear. Wildly scattered residual points suggest the data might have no correlation. Okay, when we look at our data points, all of our data points are scattered above the x-axis or the horizontal axis. So what we can say is that this model is not a good representation of our points because the residual points are not evenly dispersed about the horizontal axis. Okay, I'm going to give you an example of evenly dispersed points. Here's an example of evenly dispersed points. We have 3 on the top, 2 on the line, and 3 below. Those would be an example of evenly dispersed points. Okay, that is our first example.